At different parts of the demand curve, it can be elastic, unit elastic, and also inelastic, the same demand curve. There's also a relationship between changes in prices and revenue. And revenue rises, is flat, and also falls depending on the elasticity. I'm also going to use a table and make a lot of calculations for you and show you how to actually calculate price elasticity of demand. I start as normal. I will plot price on the vertical axis and quantity on the horizontal axis, and then draw in a blue demand curve. I'll put in some numbers because I'm going to do some calculations for you. We can ask, what happens to revenues as prices change? I'm going to show you that revenues are not constant as price falls and as price rises. So now I'm going to put in a plot. I'm going to make another plot with quantity and revenues, and I'm going to plot quantity on the x-axis like before, or the horizontal axis, and revenues now this time on the vertical axis. I'm adding a few numbers, and these numbers here, the 1 and 1, those are exactly the same on both graphs. What happens as prices fall, revenues at first begin to rise, they flatten out, and then revenues actually fall if prices fall any further. I'm going to make some calculations for you, and price times quantity demanded is equal to total revenue. So I have 10 times 1, 10 times 1, quantity demanded of 1. That is equal to $10, using dollars here since I'm in the United States. And I'll plot that right there. Now I'll plot another number and total revenue. I'm going to do 9 and 2. So I start with a price of 9 and a quantity of 2. So I have 9 times 2, and that is equal to 18. And I'll plot that 18 on the bottom graph. I'm not filling in all the numbers in between, but you can kind of see them grayed there. So I have 18 and quantity of 2, $18 quantity of 2. Now as price drops to $8, quantity demanded increases to 3. So 8 times 3 is equal to $24. So I'll plot that 24. So I have $24 and quantity demanded of 3. I'll continue on for a few more examples. 7 times 4. So I have 7 times 4, which is 28. And I'll plot that. So I have $28 and quantity demanded of 4. When I decrease price further to $6, so I have 6 and quantity demanded of 5, total revenue is 30. That's where it starts to max out. If price is 5 and quantity demanded is 6, price of 5 times 6 is equal to 30 also. Should be 30 right there. So revenues begin to flatten out. Now if I lower price any further, like to $4, so I have 4 times 7 is equal to 28, revenues begin to fall. You'll also see that the curve is somewhat symmetrical too, and I'll just be plotting in these points for you. 2 times 9 is equal to 18, and finally 1 times price of 1 and quantity demanded of 10 is $10. So the revenue curve looks something like this. First it goes up, then back down. The top part of the demand curve is elastic. The middle part is unit elastic, which is the little area right here. And I'm shading in the table as well, the light green or the greenish color. And the bottom part of the demand curve is inelastic, and I'll make that kind of a turquoise color. Now I'm actually going to calculate price elasticity of demand. And if prices fall by 10, price falls 10%, quantity demanded goes up 100%. So price elasticity of demand in this case is 10. So we take the percent change in quantity divided by the percent change in price, and this is price elasticity of demand, or PED. Now I want to show you how these formulas work. I'm going to go into some detail and show you how all the pieces of these formulas as well. If price goes down any further, so if price begins to fall from 9 to 8, we see that prices go down by 11.1%, while quantity increases 50%. So I take the percent change in quantity divided by the percent change in price. In this case, it's 3, the quantity of 3, and I'm talking about that quantity, the new quantity, minus the old quantity, which is 2, the old quantity, which is that quantity and the old quantity there, divided by the old quantity of 2 times 100. And that's the percent change in quantity demanded. Let me pause for a second and tell you how percent change is calculated. It's the new minus the old divided by the old times 100. And that's how you calculate percent change. I digress, but let's go back. So we take 8, which is the new price, minus 9, which is the old price, divided by the old price, which is 9, times 100. This is equal to 0.5 times 100 divided by negative 0.11 times 100. Economists often drop the negative sign. This is equal to 50% divided by 11%. It should be 11.1%, but I'll just say 11%. And this is equal to 4.5. So price elasticity of demand is 4.5. So when prices drop from 9 to 8, price elasticity of demand is 4.5. I'm going to do one more for you so you can get the hang of it. So when prices drop from 8 to 7, quantity goes up 33.3% when prices drop from 8 to 7, or when prices fall 12.5%. This is equal to 4 minus 3 divided by 3 times 100. All this divided by the percent change in price, which is 7 minus 8 divided by 8 times 100. And this is equal to 33, or 0.33 times 100 divided by 0.125 times 100. And again, I'll drop the negative sign. And this is equal to 33% divided by 12.5%. Anyway, which equates to 2.7. So price elasticity of demand is 2.7. So let me just fill in all the rest of the numbers for you so you can kind of see the end result here. But hopefully you're getting the hang of it now. So now I'll just shade everything in different colors so you can kind of match it all up. When prices fall and revenues increase, that's called elastic part of the demand curve, and elasticity is greater than 1. Unit elasticity is where there's no change in revenue and elasticity is equal to 1. When price decreases cause revenues to go down, it's considered inelastic, the demand curve, and price elasticity of demand is less than 1. So let me go back to the beginning. We started with a demand curve, and I showed you how different parts of the demand curve have different levels of elasticity. And also there's a relationship between elasticity and total revenues. And I also made some calculations for you too in a table, and I hope this isn't too cumbersome. And good luck.